In this lecture, let's explore what exactly do we need to successfully boot the Linux kernel on the ARM-based hardware such as Beaglebone Black or any other board which meets the requirements to run the Linux kernel. In this course, our target hardware is Beaglebone Black, and this board is powered by the SoC AM335X from Texas Instruments. You already know this, and you also know that AM335X is based on ARM Cortex A8 processor. Now, to run Linux on this embedded board, we need minimum of 4 software components. Here, the RBL stands for the ROM bootloader. That means it's a very tiny bootloader runs out of the ROM memory of the SoC when you supply power to the board. This bootloader is written by the vendor. In our case, it's written by Texas Instruments and stored in the ROM of the SoC during taping out of the chip. So you cannot change this bootloader. Also, you may not get the source code of this bootloader. This bootloader is very tiny and has limited functionalities. You cannot override the functionalities written by this bootloader by changing the source code of this bootloader. Okay, so I will discuss more about its functionalities in the later lectures, so please don't worry for a time being. The major job of the RBL is to load and execute the second stage bootloader from the internal memory of the SoC. The second stage bootloader is also called as SPL. That stands for the secondary program loader, and sometimes it is also called as MLO, which stands for memory loader. The job of the second stage bootloader is to load and execute the third stage bootloader such as U-boot from the DDR memory of the board. The job of the third stage bootloader is to load and execute the Linux kernel from the DDR memory of the board. So the booting actually takes place in 3 stages. Okay, RBL loading the SPL, SPL loading the U-boot, and finally the U-boot loading the kernel. And to complete the successful boot of the Linux, we also need a root file system for the Linux, which we'll understand thoroughly as we make a progress in the course. So don't worry about all these boot sequences. More on this will be covered from the next lecture. In this course, I just wanted to show you the software components required for the successful boot. In this course, U-boot is used as the third stage bootloader. The second stage bootloader, that is SPL, is also derived from the U-boot source code, which you will understand as you make a progress in this course. I will show you how you can get SPL out of the U-boot compilation. So to conclude this lecture, to boot Linux successfully, we need at least 4 components. One is the RBL, the second one is the second stage bootloader, and the third one is the third stage bootloader such as U-boot, and finally we need Linux kernel and the root file system. Now, from the next lecture onwards, we will thoroughly understand what each and every stage does and how we end up booting the Linux kernel successfully on the board with hands-on experiments. Alright, I'll see you in the next lecture.